Manuel with AspenCore, and we're here at DesignCon 2019, and I'm at the TE Connectivity Innovation Station. We're going to find out some really exciting technology announcements from TE concerning 5G and high-speed backplanes. On my left, I'm joined by Nathan Tracy, Technologist at TE, and I'm joined also on the further left by Rickard Barrefelt, who's going to talk about some 5G announcements. Rickard, we're going to hold off on you for a few minutes with 5G, but we're going to take Nathan on a quick tour to talk about what's happening with high-speed connectivity, backplanes, antennas even, and what else do you have in the background?
Oh, we've got thermal management, we've got high-speed, high performance, we've got all kinds of exciting announcements here.
Let's rock and roll, okay. So Nathan, as we talk about these technologies, what are some of the major challenges you're seeing?
So Patrick, the thing I want to get across in this message is that the industry is facing this data tsunami. Right. You know, everything is moving to the cloud, and it just is creating this great pressure. How are they going to deliver that data to us? You know, we want to watch videos on our phone, we want to watch our house while we're not home, we want smart homes. How is that all going to be enabled? We need to get to higher and higher data rates, and with higher data rates means there's going to be thermal constraints, there's EMI challenges, and all of those problems need to be solved in a holistic way. One piece, another piece, that doesn't work. It has to be integrated. And that's our message here. So Patrick, here, this is a demonstration where we're showing 800 gigabits per second through a single copper cable assembly. So this is using the OSFP interface. Right. It's an 8-lane interface running at 100 gigabits per lane, so 800 gig link. We're running at ridiculously low bit error rates, and we're showing the industry that we can deliver 800 gigabits with 100 gig serial signaling.
So of course with ultra high speed comes ultra high heat. So how are you addressing that?
Yeah, so you're right, Patrick, and our customers are counting on us to help them solve that problem. And so what we've done is we've developed an internal thermal management capability at TE to help them get the heat out of the hot devices, or to help them transport the heat to where they can allow it to dissipate.
Manage it elsewhere, right? Yeah.
So in this case, I'm showing a QSFP-DD connector and a new thermal solution that TE offers. And in this, you know, so normally this would be like a 5-watt envelope. Well, right. Now we're seeing performance requirements up to 15 watts. So a huge increase. And the customers want to know, how can they trust that we really have achieved that performance? Yeah. So we've developed a demonstration vehicle where we have 32 modules, just like a customer would put them in. Each one is dissipating 15 watts, and we're showing, so right now the hottest module here is running about 55 degrees C. So it gives them the confidence that when they go to their next generation equipment and they use this TE solution, it's going to work, it's going to allow them to manage their power problems.
So what do you have here?
So this is another high-speed demonstration, and in this case, again, we're hitting on the 100 gig per second serial data rate, but in this case, we're talking about how we enable new architectures to come to market. At 100 gigabits, the insertion loss of the media goes up. Sure, yeah. And so one of the things we can do to mitigate that is replace printed circuit board with cabled solutions. It's much lower loss. And so in this demonstration, we're showing a link where we're coming off of a fabric card through a cable backplane, through one of our Sliver flyover cables, right. And then back to the receiver. Or in this case, an I/O, we're coming off of the fabric card, out an I/O port, through a cable, through another Sliver cable assembly to the receive side. The key thing here is the use of our cable as a low loss media, so it enables the customer to still build big equipment, right. But he can achieve the low loss he needs because the cable is lower loss than the printed circuit board.
Lots of changes happening in backplane technology, I guess, right?
Yeah.
So what do we have here?
So Patrick, we looked at the OSFP 800 gig demo.
Yeah.
In this case, it's a similar connector. This is QSFP-DD. It also has 8 lanes, just like OSFP does. And one of the key features of QSFP-DD right. is it offers backwards compatibility to the legacy interconnect that the customer is already using. So it enables him to make a smooth transition from current generation to future generation.
Migrate upwards.
Yeah.
Future-proof it.
In this case, again, we're featuring TE's bulk cable capability, and we're demonstrating 3.5 meters of reach with the QSFP-DD cable. So again, enabling our customer to scale his data center for that data tsunami.
Very good. Okay. I think at some point we had to standardize these connectors, right? In some form or fashion.
So that's a great way that we can serve the industry.
Right.
And in fact, what we're looking at here is a new interconnect from TE. It's called Sliver.
Okay.
And really what we intended when we developed Sliver was to create a ubiquitous interface that could be used by our customers in many applications. In the case of Sliver, it's optimized to be used in storage applications. It's to be optimized for compute functions, and then it's also seen applications in networking interconnects as well. So we're bringing this one interconnect across all the equipment, and it helps our customers in terms of how they manufacture and how they buy product. This is a new standard called EDSFF,
right.
And it uses the Sliver interface as the high-speed interconnect. This demonstration is running at 32 gigabits per second, but Sliver also operates at 56 gigabits per second and has future upgrade to 100 gigabits per second.
Scale upwards over time.
And so it addresses compactness, it addresses commonality, this ubiquitous interface that I talk about, and it just makes it easier for the customer to develop their next generation of equipment.
As we get faster and faster then, don't the chips get bigger?
So
with so many connections.
It's right on the point, Patrick. So the customer's switching chips are getting bigger. They're going from 6 terabits to 12 terabits. The next step is 25 terabits and then ultimately 50. And so we've developed an LGA Socket technology that allows a customer to put this on his board, apply his chip onto it. It solves all of his manufacturing and attachment problems, and at the same time, as we're showing here, we're performing 50 gigabits per second PAM4 signaling, and you can see that we're getting wide open eyes, very good signaling, and so the customer now has the confidence that he can move to this technology, enable the next generation of packaging, and not damage his signal along the way.
Lots of really cool technology here, Nathan. Thanks for the tour across the booth. Now I got to go and join Rickard over at the 5G stand, so I'll catch up with you later.
Yeah, no, that's great. You need to see that.
Thanks for your time.
Yep.
Really appreciate it.
Yep.
So 5G is everywhere, right? We're all talking about it. So, but what does 5G mean to you?
So I would say ST is having multiple business units, everything from automotive to industrial, medical, appliance, and then other devices. 5G enables us to combine all these business units by connecting the device of a car or an appliance into the data centers through our telecom systems.
So how is TE connectivity enabling 5G from that point of view?
So I think there's 3 major topics on 5G, the whole ecosystem. It's high speed, it's thermal management, because it's one of the key technologies, and it's EMI, because there's a lot of radio frequencies which needs isolation. So especially with the telcos, we're partnering up on the thermal management. We have a demo of our thermal bridge, which we are enabling the OEMs and the big wireless customers to make sure that their system is being cooled down and the transceivers and optical interfaces. We also are enabling by our SI technology and EMI, proven interconnection cables to be isolated from the rest of the system, bringing high-speed sensitive signals from the active antenna system down to the base stations and then further into the cloud. And by our antenna technology, which we're more traditionally has come from the consumer devices and working with maybe Wi-Fi routers, it's more applicable now to the 5G active antenna systems. So MIMO approach with up to 64 to even 128 antenna elements in one of these active antenna systems. And from those antennas, we're bringing down with a new technology which we call ERFV. It's a one-piece board-to-filter or board-to-board RF connector. With this new technology, we're both saving a lot of cost. We are also enabling better manufacturing methods. It's easier with the one piece than multiple components. And we are able then to serve up to mainly for the sub-6 active antenna systems. So this one is the Full Access Mini, which is a new version. It's a little bit smaller than the Full Access, which has been around for almost 10 years. It's also IP68 proven, so we can even submerge it into water. So it can be used in more applications than just radios. For edge clouds, for example, bringing fiber optics into a very harsh environment. And then from the active antenna system through this Full Access system, we're bringing down fiber or power to the base stations. And from the base station with our high-speed interconnect and backplane solutions and all those, we're bringing that further on to the cloud and then all the way back again. I think one of the major differences with 4G compared to 5G is the latency. By bringing the cloud closer to the active antenna system, which we call an edge cloud and edge computing, you're able to compute much closer to where the devices are, and also send that information back to the device.
Thanks for the rundown, Rickard. So let's go join Nathan. So we've seen quite a bit here at TE Connectivity's Innovation Station, right? Why would somebody partner with TE Connectivity at this stage?
You know, what we looked at today was datacom and wireless connectivity, but because we're in all those other markets, the learning and the technology and the customer service, it's the global team. It's the engineering talent that we have that's helping the customer, whether it's at their site or whether it's the quality assurance in the factory or the product development in the engineering centers. It's all working together. Again, we talked about it earlier, that big picture view. Customers value that we understand their problem and we can put their hat on for a day and think about, you know, how are they going to do the next generation problem solving. We've already thought about that, and that's valuable to them.
Sums up nicely. Great. Yeah. Thanks, Nathan. Really appreciate your time.
Thanks.
Rickard, really thank you. Appreciate it.